Hello everyone, and thanks for joining the iLand Tech Talk series. Today we're going to be talking about Hyperscale versus native VMware Cloud. For those of you that aren't aware of the Tech Talk series, this is something that we recently started. This is the third one in the series, and we're going to be covering off in a short half an hour a number of different topics across the coming months at a more technical level than we normally would do so. As I said, we're going to be talking about Hyperscale versus native VMware Cloud today. But before I jump into that, I just wanted to let you guys know about the chat and the questions section on the GoToWebinar. So you might see a control panel. Everyone is muted as standard, so you're not able to vocally ask questions. But if you do have any questions or any comments that you want us to cover off during this webinar, then feel free to put your comments or questions in there. I will be saving them up till the end of the presentation and then answering any questions that you have. So please feel free to ask them throughout the process as well. So as a way of introduction, my name's Alex Crow. I'm one of the regional sales executives here at iLand, predominantly covering the EMEA region. I've been with iLand about 2.5 years, coming from a systems integrator and storage background, and work with a range of our partners and customers to define solutions across backup, disaster recovery, and also production hosting. So when we came up with the idea for this webinar looking at Hyperscale versus VMware clouds, we really kind of wanted to focus down on a number of areas where we often get questions from customers about the differences between what we offer as a VMware powered cloud and a lot of the larger Hyperscale providers offer. So what we've broken those down into is 5 sections, being Hypervisor and resilience, pricing and hidden costs, security, compliance, onboarding and training, VM performance, scalability and sizing, and RTOs and network flexibility. So given that this is a quick half an hour kind of session, we're going to be focusing on 3 of those today, being Hypervisor and resilience, VM performance, scalability and sizing, pricing and hidden costs. We will be running another session at a later date to cover off the security and compliance, onboarding, training, and also the recovery time objectives and network flexibility, as there's quite a lot of content that we could go into on those 2 topics. So starting off with the Hypervisor and resiliency, we're going to specifically talk about high availability from a VMware perspective, but also be touching on the other options that Hyperscale cloud providers put forwards for that. So whether you're looking at an on-premises solution or whether you're looking at a cloud solution, you always have to think about the hypervisor that is being used. So hopefully you all recognize the hypervisors that we've got up here, being VMware, Hyper-V, KVM, and Zen. And in very much the same way as you may go through a process of looking at the different advantages and disadvantages of running hypervisors on premises with your production workloads, you should also go through that process with looking at the cloud. So for example, people like AWS on their EC2 platform use KVM. People like Google, again, use KVM. Azure use a modified version of Hyper-V. And people like Alibaba use the Zen hypervisor. From a VMware perspective, you've got people like iLand. There was vCloud Air when VMware brought out their public cloud offering as well. And there's a whole range of other VMware-powered clouds out there. So one of the most important things from my perspective is to not just look at a cloud provider from a cost perspective or an ease of use, but actually to look down at the technology around the hypervisor. So that's what we're going to touch on initially. So just to kick things off, I wanted to be completely transparent from an iLand perspective, where we are from both a hypervisor, but also a complete infrastructure stack perspective. So one of the questions that I often get from customers is that when they're looking at hyperscale cloud providers, they're not actually aware of the underlying infrastructure stack, or it could be quite difficult for them to find out that information. So we tried to be as open and honest and transparent as possible, all the way down from the actual physical infrastructure we use and every single layer of software that we put on top of that. So I'll briefly run through this just to let you know exactly what we're running. But essentially, from a physical infrastructure perspective, we're Cisco powered. So we utilize Cisco UCS servers and Cisco Nexus switching across the environment. And that's powered by nimble flash accelerated storage. So the absolute lowest tier of storage that you're going to be utilizing would be flash accelerated, so giving you a flash cache on top of the traditional spinny disks. So the reason that we've used these kind of infrastructure is because they're extremely high performance. There's a lot of security built into this, and it also allows us to have a redundant and resilient infrastructure from the physical level. On top of that, we've built the VMware vSphere hypervisor and utilizing vCloud Director for the multi-tenanted aspect of that, which has really allowed us to utilize some of the more specific technologies such as VMware NSX for both their firewalling and their virtual networking layer as well. One of the great things that having that basis of VMware gives us is the ability to plug into market-leading products that utilize that VMware infrastructure and tie into that really well. So as you can see there, we use things like Veeam for backup and replication, Zerto for their disaster recovery, and Trem Micro deep security suites for their security elements of that. And that allows us to deliver a wide range of services on top, pulling in the APIs of all of those technologies to deliver a secure and visible cloud environment on top. So that's from an ILAN perspective. We've built in a lot of resiliency and high availability. And one of the big challenges that we see with hyperscale cloud providers is that when you move away from a VMware powered platform, you're actually taking away that native high availability from the environment. So you have to build resiliency in a number of different ways. So what I've put up here is just a bit of information around the SLAs that are provided by both Azure and AWS across the environment. You may have come across the concept of availability sets with Azure and availability zones with AWS. But this is essentially how you build in resiliency across the environment. So you can see that Azure as standard gives 99.95% uptime SLA, while they actually provide a 99.99% uptime SLA if you were to go for their SSD managed disks. These are limited in some instances, so they're not able to work on every workload, and there are some size limitations to the SSD disks. But even if you are looking at that, you are looking at a number of minutes of downtime per month, with the 99.95 being 22 minutes of downtime per month. It's very similar with AWS with their SLA, although they do have a slightly higher SLA. So a lot of people ask us about that. Obviously, 22 minutes worth of downtime is not acceptable for a lot of organizations. So they look to build in availability sets and availability zones. And there's a few challenges with that. One of which is certainly the cost that's associated with that. It's storing multiple copies of your data in different availability sets or availability zones. One of the other challenges that we've seen more recently is with GDPR, with the locations of the availability sets and availability zones being across, potentially different geographic boundaries. It does mean that your data, to give you that full kind of resiliency and high availability that you would be used to on premises, you may be looking at keeping them in different countries and different regions potentially. Just moving on to VM performance, scalability and sizing. This is probably the area that I think causes the most confusion amongst the customers that I have spoken to when looking at hyperscale or even any type of cloud providers. So what I really wanted to do here is give a typical example of an on-premises environment size and look to see how this can be deployed across various cloud options. So what I've done here is I've just taken a typical virtual machine that a customer might have on their on-premises VMware environment. So we've got two virtual CPUs running at 2.6 gigahertz with 16 gig of RAM allocated to that. And then we've got 3 disks attached to that. We've got a 100 gig disk, we've got a 50 gig disk, and then we've also got another 50 gigabyte SSD disk. So you will notice that the two initial disks are just on spinny disk, but we have also got an SSD disk. So how would that size in iland? What would that look like? Well, whether you're using this for production hosting or you're utilizing us for something like disaster recovery, we would essentially match the exact same size of disk that you're utilizing on premises. So we would match that to vCPU at 2.6 gigahertz. We'd give you the full 16 gigabytes of RAM. We'd give you those disks on spinny disk at 100 gig and 50 gig, and also an additional 50 gig disk on SSD. And this is completely flexible. So this is customizable. If you needed to increase the RAM, the CPU, add additional disks, that's not a problem. We would essentially size it exactly the same as you're doing today on premises. And that often brings up the question of Azure and AWS. How do they do it? Because iland here essentially conforms to the VMware norms, but Azure and AWS have very, very different ways of doing it. Some of you might have come across the concept of instance sizes, and that is essentially giving you a pool of CPU, RAM, and storage that you can utilize, but only can be utilized on one disk. So it's really, really important that you size that correctly. So I've got an example on the next page. It's actually a screenshot from Microsoft Azure's website at all the different instance sizes that you could select. So you can see on the left that I've highlighted the one that probably best fits our requirement. 2 cores, 16 gig of RAM, but only 20 gig of temporary storage. But as you can see, as that scales, if you needed to add additional disks, you needed to add additional cores or RAM, there is a whole host of various options. And what it often means is that actually customers are looking to oversize their virtual machines because they don't want to go through that process of right sizing the virtual machine, only to find out that they need to add more resources at a later date. So this often leads to a lot of resource that is not utilized. It often means that the cost spirals and that you're not getting an efficient environment within your AWS or your Azure instance. So when it comes to disks, that's very much the same. You can add disks to your instance sizes that you've chosen, but there are limitations around that. So on the left, I've got a screenshot of Azure, albeit a little bit out of date, and an AWS screenshot on the right of the various disk sizes. Now, the most important thing here is that there are set disk sizes. So with that 50 gigabytes of disk and the 100 gigabytes of disk that we initially looked at, they're not actually options there. You would have to size those disks slightly higher or slightly lower within your environment, which is obviously potentially restricting what you can do, or it's meaning you're having to pay for resource that you're not fully utilizing. The other thing to consider is the performance. So the IOPS per disk and the throughput can be impacted by the amount of storage that you're purchasing. So if you need really high performance disk with a high number of IOPS, you're potentially purchasing more storage than you actually need within the environment. And that's exactly the same for both Azure and AWS. Although Azure has certainly upped their limits from the 4 terabyte option that you see there. I believe they're going up to 16 and potentially 32 terabytes in the future as well. But the point here is that it's a bit of a minefield around sizing, and often leads to people oversizing their environment and therefore incurring additional cost. So now we've sized the environment, how does that scale? So we touched on the fact that virtual machines are living, breathing things. They do have performance issues that sometimes require us to increase the resources on the machines. So if we look at an island environment, how can we scale that virtual machine? Well, essentially, what we're looking at is the exact same VMware maximums that you would have been utilizing on premises. So on premises, you can have up to 128 vCPUs, 6 terabytes of RAM now, and up to 62 terabyte disks. And that's exactly the same if you were to utilize someone like iland in a VMware powered cloud, because we're essentially playing by exactly the same rules. So anything that you can do on premises, whether that is migrating into a VMware powered environment, or whether that's doing something like disaster recovery, there's not going to be any concerns over the sizing of those disks not working in the cloud environment. With Azure and AWS, it's very different. As we said, as we saw on the previous slides, there are some limitations to the sizing because of the fact that it is based on instances. So you're essentially fixing yourself to CPU and RAM. The other thing that wasn't really touched on is that there's also certain instance sizes can only support certain types of disks. So for example, SSD disks can't be used on some of the smaller instance sizes. So if you had a very small requirement for CPU and RAM, but that virtual machine needed the performance of an SSD disk, you might be forced to purchase more CPU and RAM in that instance. So essentially what we're saying here is that the vertical scaling capabilities of a virtual machine are very, very limited, and again often lead to people going for much larger instance sizes than they actually require in the environment. Taking it back to what we initially talked about as well, you've got to think about the fact that often these instance sizes are going to be spread across as availability sets and availability zones due to the fact that there's no high availability as standard. So you need to ensure that you're purchasing exactly the same instance across all of the regions that data is going to sit in. The use case that we often see for cloud is disaster recovery. And one of the biggest challenges around sizing an environment for disaster recovery in the cloud is that if your on-premises infrastructure changes and you add additional resources to a virtual machine, that needs to be replicated into a cloud environment. So with iland, that's exactly the same. It would be replicated across to the iland side of things, so that if you had to ever invoke a disaster and spin up, you would still have all of the resources as they were on premises. Whereas with some of the hyperscale cloud providers, you need to size that correctly from day one, meaning that every time you update the performance and the information on premises, you have to do that in the cloud environment as well, which obviously creates some operational issues and headaches as well. So now we've talked about scaling the virtual machine. How can the environment scale? So obviously we've picked on a single virtual machine up until this stage, but what about a typical environment that has multiple virtual machines? Well, again, from the iland perspective, we're only limited by the size of our clusters and what VMware tell us that they can support. So that's all the way up to 8,000 virtual machines. But again, Azure, AWS, and a lot of the other hyperscale providers don't have clear information on how many of each instance type that you can have. So from an SLA perspective, certainly with Azure, one of the limitations is that they will give you up to 20 instances per account and per region. So that means if you choose a D series instance, for example, that is running in a particular region, you're going to be limited by 20 virtual machines. You'll have another 20 virtual machines in all of the other regions, but you might be utilizing those availability sets because of the fact that you are looking to build in that resiliency. Now, I will say that that is not the absolute maximum. It is possible to go above and beyond that, but there is no SLA, and it's essentially on a best effort basis. So for some of the larger environments out there, you may be limited to what your the instance sizes that you're looking to deploy within those regions. There are also network considerations. I won't touch on it too much, but obviously if you've got a number of virtual machines running different instance sizes, you do need to be aware of how the networking works as well. So essentially what we're getting at here is that whether you're looking at the initial deployment, the scalability, or scaling the whole environment out, by sticking on a VMware environment, you're going to have a standard set of tools, a standard set of sizing metrics that you're used to from your on-premises environment, which don't result in purchasing additional resources across your environment than you need. So that leads us nicely onto the pricing and hidden costs with a lot of hyperscale cloud providers. So one of the things that I often talk about with customers is the transparency of services. So at iLand, we try to be completely open and honest with exactly what we charge you for, and that is from absolute day one, whether it's a quote you're getting off us or you're increasing resources in the services, you will know exactly what your unit costs are fixed for the duration of the contract for all of your services. And we essentially have, instead of instance sizes, we have a concept of resource pooling. So if you have a pool of resources, you have an amount of CPU, an amount of RAM, and an amount of storage, and a particular virtual machine is not utilizing all of that CPU, RAM, and storage, you can take that from that virtual machine and allocate it across all of your other virtual machines, so you could split it up, or you could build some new virtual machines and utilize that resource. So that allows you to be extremely accurate with how you size the environment, and also from a cost perspective means you aren't utilizing resources that that you're not taking resources that are wasted and purchasing new resources for the same use case. So essentially how we split that up is into reserve and burst pricing. So reserve is essentially guaranteeing on a month-to-month basis the amount of CPU, RAM, and storage that you think your environment is going to utilize, but with the added knowledge that you have the ability to consume unlimited resources above that and pay for that on a consumption basis per hour. So the really nice thing about that is that you can reduce your costs on a reserve basis for probably your applications that are quite consistently chugging away. They probably don't have too much on-demand utilization. Maybe they might see a quite small amount of reduction outside of the 9 to 5 hours, but generally, they're pretty consistent in their CPU, RAM, and storage utilization. But you might have a small subset of virtual machines, such as for test dev or for month-end reporting, which actually do see quite significant spikes in CPU, RAM, and storage utilization. So what you would do in that case is you would reserve the CPU, RAM, and storage for what you expect your typical month to look like. And then at those points whereby you need that additional resource, you would just utilize iLand's burst capacity, which you'll know the cost of from day one, and you'll only be charged for what is actually consumed above and beyond what has been reserved. So it's a really, really nice way to ensure that you're not paying over the odds for the services that you're running in iLand's cloud environment. That's all visible through the ILAN console. If you want to find out more information about the ILAN console, our first ever Tech Talks webinar was actually on the ILAN console. Gives you a nice 25-30 minutes overview. And one of the key things of that is the visibility around the billing as well. So at every single point, you have complete and total visibility into what you're spending in your environment, and that is going to link back to the invoices that you receive at the end of the month. So if there are any concerns around the visibility of billing, you can address those earlier rather than waiting for the invoice to turn up. So onto the questions. I've just seen that a couple of questions have come in. One of those being, can you support physical workloads? That is absolutely something that we can support. It's often one of the major considerations why people either don't look towards hyperscale cloud providers or maintain some kind of on-premises infrastructure as well as cloud environments. But at Iland, we have the ability, because we own our own infrastructure and our own cages within the data centers, we have the ability to either co-locate infrastructure or to provide dedicated blades that you could run physical workloads on as well. Got another question here. Is it possible to connect Iland's environment into other cloud providers? Absolutely, that's not a problem at all. So we sit in completely network diverse data centers, allowing multiple different connectivity methods, whether that be things like MPLS or dark fiber, through to some of the connectivity methods into people like Azure, AWS with things like ExpressRoute. Often there will be a requirement to host a small router of some sorts in our data center, which ties nicely into the previous question, as we can co-locate that router and give you that connectivity in. So whether you're using us for production or disaster recovery workloads, if you do need that connectivity into any of the hyperscale or public cloud providers, we can absolutely support that from Iland's infrastructure. I've got another question, which is, can you hot add resources to VMs within the Iland environment? Yes, that's absolutely something we can support. Obviously, that's one of the major features within VMware that allows you to increase the resources on a virtual machine without powering it down. And that's absolutely something that we can support. So if you have a look at the previous Tech Talk on the Iland console, you will see how you can interact with your virtual machines on a day-to-day basis. And essentially, it's just a case of turning that on within the console and then having the ability to hot add those resources on demand. So just before we go, and thank you very much for your time, guys, I just wanted to highlight the second Tech Talk in our series, which is available on YouTube, which shows us into the Iland Catalyst tool. So the Iland Catalyst tool is a tool that we've developed in-house, which looks to speed up the process of qualifying and technically validating whether your environment is suitable to run in the Iland cloud. We know that often cloud providers are going to go through a pretty long process whereby they will look to understand all the workloads that you're running on premises and how that's going to fit into the cloud environment. So we've really looked to simplify that by utilizing a lot of the tools and information that's gathered from your underlying on-premises vCenter to allow us to do things such as size the environment, get pricing out to you very, very quickly, but also to maybe highlight some areas that might need a bit of additional investigation as well within the environment. So I'd highly recommend that you take a look at that. My colleague has also posted a link to the Iland Catalyst tool within the chat function. So if you are interested in finding out a little bit more, I'd highly recommend you look at that Tech Talk, and then if you fancy running the Catalyst tool to learn a little bit more about your environment and potentially to have a discussion around what you could do with Iland, take a look at that link and see if you can get that run. Just before we leave, just wanted to highlight some of our other upcoming Tech Talk webinars. We've got one scheduled for November, which is looking at the ILAN Secure Cloud Backup with Veeam Cloud Connect. This is one of the products that I'd say the majority of our customers utilize because it really is super simple. And staying on that same theme, in December, we're going to be looking at the ILAN Secure Cloud Backup for Office 365 with Veeam. So really great product there, no prerequisite to be utilizing Veeam on premises. So if you are looking at backing up some of your Office 365 workloads across your organization, I'd highly recommend you sign up to that webinar. If you do want to pass this webinar along to any colleagues or any of the other webinars that have already gone on, they are available on our YouTube channel and across our website. So I'd like to say thank you very much to everyone for joining today. And if you are interested in finding more, please go to our website, ilan.com. Thank you.